Hello, today we will be studying the concepts of chemical reactions and reaction equations in detail. However, prior to moving forward, let us remind ourselves that chemical reactions are accompanied by certain alterations and modifications. This has the potential to be a modification. State has the potential to undergo a modification in aggregate state, which has the potential to take place during a reaction. The second thing might be a modification in color. The second thing, it might be a modification, for instance, of color. During the reaction, let's assume we could refer to this process as the formation of rust. Then there is a possibility of certain modifications occurring, such as the formation of gas. The process of gas formation is exemplified by the interaction between acid and carbonates, which leads to the production of carbon dioxide. This chemical reaction can also cause a variation in temperature, specifically measured in Celsius. For instance, an increase or decrease in temperature may accompany the formation of gas as a result of this interaction. Chem reactions are like when things mix and stuff occurs, and you can tell it's happening due to signs of the reaction. In what way do we represent chemical reactions? What notation and symbols are used to depict these reactions accurately? Chemical equations are a reflection of chemical reactions. What's a chemical equation? This is an elaborate technique for expressing a chemical reaction by utilizing chemical formulas and coefficients in a sophisticated manner. In order to write such an equation, we must have knowledge of a multitude of rules that they adhere to when writing this type of chemical reaction notation. To begin with, the reagents and reaction products are separated into the left and right sides, giving utmost importance to this step as the very first and foremost stage of the process. For instance, let's imagine a situation where we have aluminum and sulfur interacting with each other, leading to the creation of a compound known as aluminum 2s3 through a chemical reaction between the two elements. During that time, aluminum and sulfur were commonly referred to as reagents. And this specific side is commonly referred to as the left side of this particular reaction. Or, to put it in simpler terms, one could say that it is the side located on the left-hand side. Once more, in the event that there are numerous of these substances on the left side, then the sign is positive. At this moment, the contents on the right side represent the products of the reaction. And in accordance with this particular side is designated as the right side of this chemical reaction. All right, now if there are several of these substances on the right side, we connect them with a plus sign as well. Now that we have acquired this chemical reaction completely figured out, it must be balanced. There is no doubt about it whatsoever. So, we will have a discussion about how such interactions are equated in the upcoming lessons. But in this equation, let's put them. One of the methods of equalization is the so-called index method. That is when this 2, the index that stands after aluminum, is placed here, and the index that stands after sulfur is placed as a coefficient here. Note that there is always an arrow before the equalization between the left and right sides. This arrow shows that the direction in this chemical reaction is going exactly in this way. And for the future, I want to say that if this reaction were possible in the opposite direction, that is from products to starting materials, then we would have put the arrow the other way around. But when we equate, then accordingly in this case we should put the sign. But let's consider another example where we will use precisely the proposed scheme. Let us suppose that we have an interaction occurring between phosphorus and oxygen. Phosphorus and oxygen are substances that have the capability to interact with one another. On the right side, we end up with P2O5. Well, let's figure out what the reagents are in this case. The reactants are phosphorus and oxygen. They are written on the left side, so essentially this is the left side of this chemical reaction. So what do we have on the right side then? These are the products obtained from the reaction, so here we recorded what we obtained. All right, in that case, we need to equalize. One way to achieve equalization is through left to right equalization. However, if we initiate the process with phosphorus, we will ultimately obtain fractional coefficients. So in the upcoming lessons, I will explain to you how you can work with these equations without making use of fractions. And in this case, I'll start with oxygen. Those that we have on the left and right are predominantly in quantity, and then the overall multiple in this case will be 10. Divide 10 by 2 and we get a coefficient of 5. Divide 10 by 5 and we get a coefficient of 2, and so on for phosphorus. Here he's alone. On the right there are 4 of them. Then let's put 4 here. This chemical reaction is balanced. The most crucial aspect to consider when dealing with a chemical equation is that it must always be in a state of balance. And we'll talk about the methods it will be equalized by on the next lessons. But let's provide another example. Let's assume that we have sodium interacting with hydrochloric acid. This is a substitution reaction, as we'll later discover, based on chemical reaction types. So then on the right side, we end up with sodium chloride and hydrogen gases released. So, like, what are the reagents in this case, Reagents on the left side, notice that they are once again connected by a plus sign. This is the left side of this chemical reaction. What are the products of the reaction in this case? And in this reaction, 2 products are obtained. These products are sodium chloride and hydrogen gas. And I draw your attention to the fact that once again there is a plus sign. So it turns out that this is the right side. And on the right side we currently have 2 substances. However, once again, as it is necessary, here we will have to equalize. Okay, let's begin with hydrogen. Here he is by himself, here he is in pairs. Then we will add a coefficient of 2 before HCl. Then we will put a coefficient of 2 in front of sodium chloride. And let us finish with the 2 before sodium. So we could interpret this equation as follows. 2 multiplied by 3 added to 2 hydrochloric acid equals 2 multiplied by 3 hydrochloric acid plus hydrogen gas. Left and right sides here hopefully clear. Well, let's give another example, shall we? Let's assume that nitrogen and hydrogen undergo a reaction. Both of these substances exist in the form of gases. Once again, what are they? Located on the left side of our chemical reaction, what do we ultimately end up with? So it turns out we've got some ammonia here. This is the famous Gabor-Sindus reaction, and in this case, the left side consists of nitrogen and hydrogen substances, while ammonia is located on the right side. So in this case, there is only one product of the reaction. Now what do we need to even things out? We got to set the coefficients. And here I would like to show a sometimes used method of equalization called indexing. It has been revealed that the index 2 for nitrogen is actually designated at this point as a coefficient with the intention of achieving nitrogen balance. Now we've got nitrogen on both sides, 2 each, and the index that stands for hydrogen is put here and it becomes 3H2. Now the equation is set equal. We can interpret it like this. 2H2 plus 3H2 yields 2NH3. But unlike all the first chemical reactions discussed, this reaction is reversible. If the reaction is reversible, please check if both the forward reaction and the reverse reaction are indicated in it. But if the reaction is irreversible, like this one, then in this case the sign is placed only in one direction and after balancing the sign of equality. So what were we up to today? We were messing around with chemical reactions, reminding ourselves what can happen, what kind of changes occur in these reactions, and showing what chemical equations look like, how they're governed by certain rules, and demonstrating some methods of balancing them. However, I must inform you that balancing chemical reactions is undeniably one of the most challenging tasks, in my opinion. Students frequently make mistakes when setting coefficients. And in the upcoming classes, we will learn, and I will demonstrate various methods of balancing, so that you can certainly balance such equations and you can confidently state, I was able to balance this chemical equation and I achieved success. Well, that concludes everything for today. Goodbye.